I'm Dr. Sandhya Patnaik, Assistant Professor, EC Department, Narula Institute of Technology. I'll be discussing about cyclic codes today. The cyclic codes are the subclass of linear block codes. N, K linear block code is said to be cyclic if it follows two properties of it. One is a property of linearity and other one is a cyclic property. So what do you mean by linearity? Linearity means, say, there are two codes there are two code words Ci and Cj. So Ci plus Cj will result in another valid code word Ck. Ci is a code word and it perform modulo 2 operation with Cj, or the exclusive or operation with Cj. You will get Ck, which is also a valid code word. The linearity has its own importance. From the property of linearity, we get the distance, that is the minimum distance value, as well as we get the information related to the error correcting and detecting capability of the code word. The second property is the cyclic shift. The cyclic shift here means, say, there is a code word C with n number of bits in it. Cn-1, Cn-2, C1 up to C0 is a code word. Then the cyclic shift of means over here we either shift the bits by one position towards left, or we can go for a cyclic shift towards right by one bit. So when we go for the cyclic shift of the bits by one bit towards left, the Cn-1 bit will be the first bit now. So here the new code form will be equal to Cn-2, Cn-3, C0 and Cn-1. Similarly, by shifting the bits present in C1 by one bit towards left in a cyclic manner will result in the code C2. So the code C2 is equal to Cn-3, Cn-4, C1, C0 up to Cn-2. So in this way, by performing n-1 cyclic shifts, we get the n-1 new code words which are cyclic in nature. Let me take an example, that is, let 101111 is a valid code word. Then by shifting the bits by one bit towards left in a cyclic manner, we get a new code word 01101111. So this code word which is generated is a valid code word of its cyclic property. When similarly the property of linearity states that if we perform exclusive of operation, that is a modulo 2 operation between the two code words C1 and C2, it will result in a valid code word C3. XOR operation. So 1 XOR 1 will get 0. 1 XOR 0 you get 1. 0 XOR 1 you get 1. 1 XOR 1 you get 1. 0. 0 XOR 1 you get 1. So in this manner we get the another valid code word, that is your C3. Let us take an example whether the codes C1, C2 and C3 are cyclic or not. Here we see that C1 and C3 are cyclic in nature, but C2 is not cyclic. So C1, C2 and C3 are not cyclic. Now, before going to the generation of the cyclic code, let me explain the polynomial representation. The cyclic codes can be generated using the matrices, but it is more convenient by applying the polynomial representation. I'll be also discussing the fundamental operations like addition and division in the cyclic codes. So let us consider an n-bit word an-1, an-2, a1, a0. The polynomial representation of this is equal to an-1 into x to the power n-1 plus an-2 into x to the power n-2 plus an minus 3 into x square n minus 3 plus a2 x square plus ax plus a0. The n components of the word form the polynomial coefficient. So here, let me take an example. P1x is equal to 0, 1, 1, 0, 1, 0. How to represent this code in the polynomial form? So here you might apply 0 multiplied with x0 plus 1 multiplied with x power 1, 0 multiplied with x square, 1 multiplied with x cube, 1 multiplied with x to the power 4 and 0 multiplied with x to the power 5. So this gives the polynomial x power 4 plus x cube plus x. Similarly, P2x 0, 0, 1, 0, 1, 1 is equal to x cube plus x plus 1. The highest power over here is the degree of the polynomial, and it is equal to the highest power of the polynomial with a non-zero coefficient. So say for P2x, a non-zero coefficient with the highest power is x to the power 3. So the degree of the polynomial is 3. Now we perform polynomial addition. The polynomial addition between P1x and P2x. P1x is equal to x power 4 plus x cube plus x, and P2x is equal to x cube plus x plus 1. So P1x plus P2x will be equal to x power 4 plus 1. So what we see here is when we perform the addition operation, x3 in P1 x and x2 in P1x will cancel off. That is because of the modulo 2 operation. Similarly, x will also cancel off. Next we go for is the polynomial division. We consider the division of P1x by P2x. So P1x is equal to, say, x to the power 4 plus x cube plus x, and P2x is equal to x cube plus x plus 1. We need to find out the remainder of P1x by P2x, and it is given as Rx is equal to remainder of P1x divided by P2x. So how do we perform the polynomial division? So we divide x power 5 plus x power 4 plus x with x cube plus x plus 1. So we apply x square over here, so we get x to the power 5 plus x cube plus x square, and the remainder which we get over here is x power 4 plus x cube plus x square plus x. We perform the modulo 2 operation over here, and we see that it can be further divided by this. So we further divide x cube plus x plus 1 with we multiply with x, we get x power 4 plus x square plus x. So here again we x power 4 and x square will cancel off, x square and x square will cancel off, x and x will cancel off. So we get the remainder x cube, which is further divided, and we get a remainder of x plus 1. So this is a remainder of x plus 1. The remainder x plus 1 we get when we divide x power 5 plus x power 4 plus x divided by x cube plus x plus 1. So this remainder which we're getting, and this division process is important because this similar process is applied for generation and the demodulation of the cyclic codes. So P2x is equal to P1x multiplied with Qx plus Rx. Qx is a quotient and Rx is a remainder. So here this is called as a Euclidean division algorithm. Now we go for the generation of the cyclic code. The cyclic codes can be generated by the generator polynomial, which is of degree n minus k and is factor of x to the power n plus 1. Say m is a message bit sequence that is represented by k bit of messages, that is message bits, mk minus 1, m2, m1 up till m0, and ck is a code word and it is an n bit code word, so we represent it as cn minus 1 into x power n minus 1 plus cn minus 2 multiplied with x power n minus 2 up till c1x plus c0 in the polynomial form. Similarly, m of x, mx, that is a message, is also represented in the polynomial form, as well as the generator polynomial is given as your gx. Here, there are two ways of generating